Suppose the block is sliding freely to the right. That means there's no applied force at 8.9 meters per second. In what time will the block be brought to a halt? So I think this is F equals ma, then suvat. Okay, so let's draw a picture of this guy. It's sliding to the right. The only force acting on it would be the force of friction, which would go this way. So we would have negative 18.2466. This guy's not relevant. This guy we calculated in part A of this. So go back and look at that if you don't know where that comes from. It's basically this times 9.81. Okay, let's see. That's okay, so this is our only force. So let's figure this out, right? This is negative 18.2466 is our only force, is equal to 6 times A. So let's do this. Negative 18.2466 divided by 6. And I get that the acceleration is negative 3.0411 meters per second squared. Now, it's interesting to note at this point, really, that this was just mu times m times g. Right, so literally what we did is we said mu times m times g, negative that equals ma. That's what we're doing here. Here's negative mu mg, that equals ma. Notice the mass cancels, so our acceleration should just be 0.31. Negative 0.31 times 9.81. Try that. Just take your calculator and do that. Negative 0.31, the coefficient of friction, right, times 9.81. You get exactly the same number. So that's a shortcut you can use if it's just sliding freely, right? So now we got to suvat this, right? So it's moving at 8.9 meters per second to the right. And then we want to bring it to a halt. So final velocity is 0. Our acceleration is this guy, right, is negative 3.0411. And we want to know time, so I guess we use no s. .90. Right, really it's just going to be this divided by that, right? But positive, right? Okay, so let's see. 8.9 divided by 3.0411 is 2.93 seconds. It's 2.92657, so I'm just going to say 2.93. Ta-da. Classic problem, eh?